Yeah, welcome to today's class. Today we want to look at initialization of arrays. We've done the first two classes. I've given you introduction to arrays, properties of arrays. Now I want to look at initialization of arrays. Now there are two major ways you can initialize an array, right? Initializing an array depends on where the values are coming from. So the two major ones I'm going to use here are what? The first one is what? Compile time initialization, right? And then the second one is what? Run time initialization. So in this class today, I'm just going to show you this compile time initialization. And then in the next class, I will show you runtime initialization. This one, you use scanf function to do it, right? So let's look at this compile time initialization. Now I'm going to write a little program to just show you that. Now the first thing I will do is include stdio.h, and then I'll declare my main function int main. Then here I'm going to declare an array. So I'll say int max, right? And then I'll say 5. So here now I'm going to initialize it. That is compile time initialization. So I'm just going to, inside my initializer, I'll say 80. Let's say 80, 85, 90, 95, 65, right? And then I'll close. So this is me initializing the array at compile time. So the compiler knows values that is going to store in the memory. So what will be the memory size of this array? Integer is 4 bytes, right? Multiply by 5, which is 5 elements. So that will be what? 20 bytes. The landmass that will be allocated. So inside the memory, 20 bytes will be allocated to this array. Now, this array is known as what? A one-dimensional array. One-dimensional array. And don't forget, memory is like this. Memory is like this. So I'm just going to have 1, 2, 3, 4. So indexing will be what? Starting from 0, 1, 2, 3, 4. That is the indexing. How you'll be able to access this value of the array. So this one now, I'm putting 80 here. I'm putting 85 here. I'm putting 90 here. I'm putting 95 here. I'm putting 65 here. So this is max. Now, the address of this, I'm assuming it to be what? 100. This one will be what? 104. Because of the integer size. The next one will be what? 108. This one will be 112. And this one is 1116. Right? This will be the address, but in hexadecimal. So for the sake of this class, I'm just assuming. Now, one-dimensional array is going to be stored in this way. Subsequent classes, I will teach you multidimensional arrays. So don't miss this class. It's very important. So I've declared my array, and then I've initialized it at compile time. So the compiler knows the values is going to put inside the memory. Now, if I do this, and then when I declare this array, then I supply at initialization, I just do 80 and 85. Then I close it. It means that the system will still allocate 20 bytes to it. But this place, and this place will carry what? 0, 0, 0 value. But if I declare this array, say max 5, and I don't assign any value to it, the system, because it is what? Integer, is still going to assign 20 bytes. But the values will be what? Will not be 0. The values will not be 0. It will be what? Garbage values. So if I try to print out the value of this array, it can give me any value. You understand? So this is me declaring my array and then initializing it. If I now give smaller value, meaning I'm not giving the 5 element, I'm supplying only 2 elements, it will assign 0 to the other ones. But if I declare an array and I don't assign a value to it, it will give me garbage values. It will only assign the space, just like a field with grass growing on it, right? That is what I want to show you. So now I've declared my array and I've assigned value to it. These values are stored in the array in memory location. You will not see it on the screen. I told you what you are seeing is not the reality. What you are seeing is a projection of the reality. So what has been stored, we are not going to see it on the screen. It's stored in the memory. If I now want this to be projected on the screen, then I will have to bring in my for loop to do that, to traverse this array. So I will say for. I will declare a variable, which is the index, because I'm going to use index to access this. So this one will be what? Index 0. This will be 1. This will be index 2. This will be index 3. And then this will be index 4. So I'm going to declare a variable for this, my index. So that will be int I, assign 0 to it. Then I less than 5. I plus plus. Then I'll come in. So in this place, I will say printf. So I can now call my printf function, which is gotten from this stdio.h. So you are seeing the application of a for loop now. So you can use a for loop to access values inside the array and then project them on the screen. So printf, then here I will say max, right? Percentage d, percentage d. Then I can do this slash n. Then for this one, I will supply I. And then for this one, I will supply max. Right? So that is how I'm going to. So I can now come here and I'll close my for loop and I will say return 0. Then I will close my main function. So this is how I can project these values of the array on the screen. So this is a string literal. This one will now print out max. This place is expecting I. So this is what? 0. Then this one will expect this value. So this is how you are accessing. These are you're accessing the values of the array. Max I. So max 0 will give you what? 80. Then it will come to a new line. Max 1 will give you what? 85. Then max 2 will give you what? 90. Like that. And then it will display all these values on the screen for you to see. So this is how you initialize an array at compile time, right? At compile time. Compile time. So these are initialize an array at compile time, meaning these values are hard coded into your code, your program, and then you can now access it using a for loop to print it out on your screen if you want, or you can do a for loop and then do arithmetic addition, or sum it up, or calculate the average of all these values. So that's just what I want to show you in this class. In the next class, I'm now going to show you how to initialize an array at runtime using scanf, and then we'll also print it out. So you use 2 for loop. The first for loop will be to initialize the array. The second for loop will be to print it out on the screen. So don't miss that class. So till we see in the next class, bye bye. But let's go to code block and let me run this for you to see. These are code block, and I'm just going to demonstrate the compile time initialization. So I will run this script and then you will see what the output will be. So this is, you declare an array max with 5 elements, and then the 5 elements are supplied. So I'm just going to run it and see what the output will be. So let's execute it. So you see the output is 80, 85, 90, 95, 65. That is, this is hard-coded into your program. Now, if I now supply just 2 elements, then let's see what the output will now be. You see, now it's giving you 80 and 85, then the remaining 3 values will be what? 0, 0, 0 assigned to it. That is what I am saying. Now, if I don't give a value to it at all, I declare the array and I don't initialize it. Now, let's say I do this and I don't initialize. Then I try to print. It's just going to give me garbage value. So let's run this and see. Now you see, it's just giving me any values. It's giving me this, 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 and then if I run it again, see, garbage values, any values. So at position 1, it's giving me this, 2, 3, 4, 5, because I didn't assign a value to it, right? So that is what I want to show you in this class. So in the next class, I'm just going to show you how to initialize an array at runtime. So till we see in the next class, bye-bye.